Hi, welcome or welcome back on C-Square. In this video clip, we're going to talk about arithmetic series. So first of all, let's see. We have two examples here of two series, finite, right, and infinite series. Okay, and as you notice, a series is nothing else than a sum of the terms in an arithmetic sequence. Okay, there is a formula we can use to find that sum. So let's take a look to some example. Here we need to find the sum of these two arithmetic sequence, and this is probably the easiest case because we can count the number of terms 1, 2, 3, 4, 5, 6. There are 6 terms, and the common difference is going by 3, right? If you want to see that, but we don't really need that common difference. So why? Because the formula said Sn equals n over 2 a1 plus an, a sub 1 plus a sub n. Okay, so in our case, we're going to have the partial sum, which also can be called as sub 6 equals 6 over 2, right? Because this n is 6. And the first term is 2, and the last term is 17 in this arithmetic series. So we end up with 3, right? 6 divided by 2 is 3 times 19, easy math, 57 for this arithmetic series. S sub 6 is 57. So pause this video, you can try number 2. If you end up with 78 for this arithmetic series, that will be great. These probably are the cases where most of the time you're going to have to work on. And you notice on this number 3 and 4, you cannot really count how many terms. So how do we find how many terms? If you remember, we have a formula that looks like that, right? This is the formula for nth term of an arithmetic sequence. In this one, we're going to plug 62. This is the last term equals 2. This is the first term plus n minus 1. And now again, we're going to look to this sequence, and we do need this common difference, which in this case is 3. Okay, so as you notice, this is an equation in n. I think the best way to solve it is by subtracting 2, right? And then dividing by 3, that will give you n minus 1 equals 20, so n will be 21. I think it's easier than distributive property, but also you can use distributive property here. So now we know the number of terms, so we can really go to that formula we had in the previous line as n equals n over 2 a1, a sub 1 plus a sub n. So in this case, we have S21, right? We have 21 terms in this partial sum. 21 over 2 times the first term is 2, the last term is 62. So we have 21 over 2 times 64. We can simplify and then use a calculator. 21 times 32, that will be 672. Pause this video clip and try number 4. If you end up with 253 for the sum of the arithmetic sequence and number 4, then you did a wonderful job. But let's take a look to two more examples. Again, the same story. We're going to need to find how many terms we have in this sequence. Okay, so we notice here for 2 to -1, we're going to have to subtract 3, and it's the same story for the other terms. So an will be, if you remember, the last term in this arithmetic sequence, which is -31, equals +2, this is the first term, plus again n-1, don't forget the n-1, times the common difference -3. So subtract 2 here to cancel out these two. That will be -33 equals n-1 times -3. If you divide by -3, which will be the next step, right, we get n-1 equals 11. So n will be 12. We have 12 terms in this arithmetic series. So we're going to have now to use this formula. And we have S12, right? S of 12, the sum, the partial sum of the first 12 terms of this arithmetic series is 12 over 2a1, 2 plus -31. So we end up here with 6 times -29. That is S12. So let's see how much that is. -174. This is the partial sum of this arithmetic sequence. Right. Pause this video clip and try number 6. If you end up with -1576 for this number 6, then you did a wonderful job. If you enjoyed this math video clip, don't forget to click the like button down right and come back on C-Square for more examples.